Greetings, ladies and gentlemen. Thank you for joining me. If you're coming across this channel for the first time, thank you for joining me. The returning viewers, I really appreciate you for your support. Come with me as we solve this question together. This is Further Mathematics. This is Senior School Certificate Examination, NECO 2024, and this is question 10 from the optional part. As I said, this is Further Mathematics. Question 10a, we have question 10a here. Then in my next video, I will solve question 10b. The question is very long. That is why I decided to solve A first before question B. Let's look at how we can handle this together. The question reads, a sequence of numbers, we have the first term here. We can either use U or T to represent terms. So we have the first term, which is U1, U2, U3. That's first term, second term, third term, in that order. Satisfy the relation, bracket open, 3k minus 2, close the bracket. Then we have k plus 1 times will be equals to, bracket open, 3k plus 1, bracket close, then k times for all positive integers k. We are given if the first term, that's u1, is equals to 1, we are asked to find Roman numerals 1, the third term, and the fourth term, respectively. Roman numerals 2, an expression for an expression for k term in terms of k. Roman numerals 3, the sum of the first k terms of the sequence. Roman numerals 4, the value of k terms plus u plus k plus 1 times plus k plus 2 times when k is equals to 10. First thing to do is to identify this question is from which topic. Of course, this is from sequences and series. Let's look at the pattern of this sequence so that we'll know whether it is arithmetic progression or geometric progression. We are talking about for all positive integers. What are positive integers? Positive integers are whole number that is greater than 0. Whole number that is greater than 0. That is counting numbers. 1, 2, 3, 4, 5, like that. The negative integers are whole number that are less than zeros. That's -1, -2, -3 in that order. So if k are positive integer, it means k can take a value of 1, 2, 3, 4, 5, 6, 7 in that order. So let's look at the pattern of this sequence. Okay? Our first thing to do, we write down the solution. Okay? We have this relation. Let's write down the relation. We have 3k minus 2 into k plus 1 term is equals to 3k plus 1 multiplied by k times. This is the relation that was given to us. So we are told that the first term is equals to 1. Okay, when k is 1, how is this relation going to be? Let's say when k is equals to 1, we are using our positive integers now. When k is 1, let's substitute and see. Anywhere we see k, we put 1. 3 times 1, that's 3 minus 2, that will be 1. We'll have 1 plus 1 term will be equals to 3 times 1 is 3 plus 1, 4. That will be 4 times 1, 10. So we have the second term now will be equals to 4 times first term from the question is 1. So we can put 1 here. So it means the second term is equals to 4. So the second term is equals to 4 and the first term is equals to 1. So let's look at the pattern of this sequence. If u1 is equals to 1, comma, then u2, that's the second term, is equals to 4. What's happening here? Let's look at this very well. From 1 to 4, it's increasing by what? 3. So it means this is an arithmetic progression because it's increasing by 1. It means, how do we know that whether it is an arithmetic progression? If we subtract second term, if we say second term minus the first term, and we subtract third term minus the second term, and it's giving us the same result, it means it is arithmetic progression. So from 1 to 4 is increasing by 3. So we can easily find third term and the fourth term. The pattern of this sequence is 1, comma 4, from 1 to 4, meaning it has increased by 3. Add 3 to 4, that will be 7. Add 3 to 7, that will be 10. Add 3 to 10, that will be 13. So the sequence is increasing by 3. Very important. And we can easily solve Roman numerals 1 because we are told to find third term and fourth term. So let me write Roman numerals 1 here. So it means our third term from here is nothing but 7. Very easy. Then our fourth term is nothing but 10. We can easily get fifth term, which is 13. Just increase it by 3. Then you get the next term. So this is the solution to Roman numerals 1. Let's move to Roman numerals 2. As I said, it's very easy. Let's move to Roman numerals 1. Let's move here to achieve that. Okay? Next question now. We are asked to find an expression for k terms in terms of k, meaning make k times the subject of the relation. From this relation here, we have 3k, minus 2, all in bracket, u, that's k plus 1 time, will be equals to 3k plus 1 multiplied by k times. We are asked to make k times the subject of the relation. That's the subject of the formula. Very easy. Let's divide through by 3k plus 1. Divide through by 3k plus 1. We can divide this. That will be 1. We are left with k times. So our k times now will be equals to bracket open 3k minus 2 multiplied by k plus 1 term divided by 3k plus 1, all in brackets. So this will be the solution to Roman numerals 2 because we are asked to make k times the subject of the formula. That's what it is. Let's move quickly to Roman numerals 3. Very easy and you enjoy it. Roman numerals 3, we are asked to find the sum of the first k terms of the sequence. Sum of arithmetic progression when the last term is not given. Let's write down the formula first. Sum is equals to n divided by 2, the square bracket 2a plus number of term minus 1 times the common difference close the brackets. Okay, but in this case, we are using k as our n. So let's substitute k for n into this sum formula and see what we'll have. So we'll have sum now will be equals to k divided by 2 into the square bracket 2a plus k minus 1 close the bracket times d. So this is the formula we're going to use because we are using k for n. Okay, so at this point, from the pattern of our sequence before, we say the first term is 1, second term is 4, third term is 7, then the fourth term is 10, the fifth term is 13, in that order. This is the pattern of our sequence, and we say it's an arithmetic progression. Okay, so let's substitute for A. Anywhere we see A, we put 1. Anywhere we see D, we put 3. Our first term here is 1, then the common difference is 3. So let's do the substitution. It means anywhere we see A, we put 1. So the sum now, k, will be equals to k divided by 2 into the square bracket 2 times 1 plus k minus 1 times 3, which is the common difference. So let's simplify this to get the sum now. Okay? To do that, our sum now will be equals to k divided by 2, bracket open, this is 2 plus, let's clear this, 3 times k, 3k minus 3, close the bracket. We have sum now will be equals to k divided by 2, 2 minus 3, that would be minus 1. So we'll have 3k minus 1. Let's simplify this. So the sum now finally will be equals to k times 3k, that will be 3k squared minus k divided by 2. So this will be the sum. We are asked to find the sum of the first k terms of the sequence. So this will be the sum of the first k terms of the sequence. The last but not the least, we are asked to find the value of k terms plus k plus 1 times plus k plus 2 times when k is 10. When k is 10, let's substitute. So we are solving Roman numerals 4 now, which is the last part of this question. So let me clean up to this point, so that we can have enough space. Okay. Roman numerals 4 now, we have k times plus k plus 1 times plus k plus 2 times when k is equals to 10. Let's substitute k equals to 10 now. So we have 10th term, 11th term, then 10 plus 2, that's 12th term. We can easily get this. Do you know why? We know the pattern of our sequence. The pattern is 1, 4, increase it by 3, that will be 7, increase it by 3, that will be 10, 13, increase it by 3, that will be 16, increase it by 3, that will be 19, increase it by 3, 3 plus 19, that will be 22, 25, 28, increase it by 3, that will be 31, that's 28 plus 3 is 31, that will be 34, that will be 37. This is the pattern of the sequence. So we can easily get the 10th term. Let's get the 10th term now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th term is 28. So we have 28 plus the 11th term will be 31 plus the 12th term will be 34. So let's sum this together. So let's sum it. That will be 28 plus 31 plus 34. That will be 93. So the solution to Roman numerals 4 is 93. Let's still check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be our 10th term. Then the 11th term will be 31. The 12th term will be 34. It's increasing by 3. As I said, if you check this, the difference will be 3. 4 minus 1 is 3. 7 minus 1, 3. This is 3. This is 3. This is 3. 19 minus 16 is 3. 22 minus 19 is still 3. 25 minus 22 is 3. You see that the difference is 3. That's the common difference now. So the 10th term, as I say, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 28. The 11th term is 31. The 12th term is 34. Sum it. That's 28 plus 31 plus 34. That will give us 93. So the value of k times plus k plus 1 times plus k plus 2 times when k is equals to 10 is nothing but 93. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to my YouTube channel at TJ's Maths and Further Maths Adventures. You can follow me on TikTok and Instagram. In my next video, I will solve the B part of this. As I said before, this is 10A. We have 10B. Look out for that in my next video. Thank you for